Hi friends, have you wondered why the sky is blue but the clouds are white? Why the sun appears red at sunrise or sunset? Why we can see a beam of light in a room filled with dust? Why danger signal lights are always red in color? Is it due to reflection of light, refraction of light, or dispersion of light? The answer is none of these. It's due to a completely different phenomena known as scattering of light. And that's going to be the topic of this video. I'm going to make the concept of scattering of light really easy for you. First, let's understand what is scattering of light. If I switch on this torch, can you see the beam of light? No, because light is invisible. But when I place my hand, or if you place a screen, then we can see the light, because we are seeing the reflection of the light by the hand. Now let's imagine this room is filled with dust, or like you see in the movies when the detective enters the dark and dusty room with his torch. Yes, then you can clearly see the beam of light. Why is that? Because the large number of dust particles are scattering the light, so we can see the beam of light. Similarly, we can see the beam of light when light is passed through a colloid. But the beam is not visible when light is passed through a solution or a suspension. Now, do you remember what is this known as? That's right, it's called Tyndall effect. Tyndall effect is due to scattering of light. Colloids show Tyndall effect, but not solutions and suspensions. So it can be used as a test for colloids. As we discussed, light is scattered by dust. But light can be scattered by other particles as well, such as air molecules and water droplets. Now let's take a closer look how these particles are scattering the light. Well, it depends on which theory of light you're considering. If we consider light as a wave, then we can say that these particles are reflecting the light waves in different directions. So it's like scattered reflections, and we say that the particles are scattering the light in random directions. Now if we consider light as a particle made up of photons, then we say that these particles are absorbing the photons and re-emitting them in different directions, in different random directions, and so we say the light is scattered. Now, do all these particles scatter the light in the same way? The answer is no. Let's go ahead and compare their scattering. Before we analyze scattering, let me ask you, what is the color of white light? Is it really white? That's right, white light is made up of millions and millions of colors. But for simplicity, we take it as the 7 rainbow colors or the 7 Vibgyor colors. In this video, we'll simplify it even further. We'll just take the 3 primary colors, red, green and blue. Now, are the different colors scattered in the same way? The answer is it depends on the size of the scattering particles. So let's take a look how the different size particles scatter light. The atmosphere is a mixture of many different particles, such as air molecules, water droplets, dust particles, and so on. To study the scattering of light by these different size particles, we are going to divide them based on the wavelength of visible light. Wavelength means the length of one wave. So do you know what is the wavelength of visible light? The correct answer is the range is 400 nanometers to 700 nanometers. So we are going to divide these particles into 2 categories. Are they smaller than the wavelength of visible light or larger than that? The air molecules have a very tiny size. They are smaller than 0.4 nanometers or even less, because the air molecules are made up of nitrogen and oxygen molecules, and they are really tiny. So these particles are smaller than the wavelength of visible light. And the water droplets and dust particles, these are much larger than the wavelength of visible light. To give you some rough numbers, the size of these particles is larger than 1000 nanometer or 10,000 nanometer or even more. So clearly they are larger than the wavelength of visible light. We'll first analyze the scattering of the light by these larger particles, that is the water droplets and the dust particles. Let's say white light from the sun is falling on larger particles such as dust particles. For simplicity, let's consider the white light to be made of the three primary colors only: red, green and blue. Let's focus our attention on only one dust particle. The dust particle scatters all the colors equally. So as you can see, red, green and blue are scattered equally in all the directions. So the white light, when scattered by this dust particle, appears white in color. An important point to note is that most of the light passes straight through. So most of the sunlight just goes straight through and only a small percentage is scattered by the dust particles. Now when you shine a torch in a room full of dust, what do you think will be the color of the beam of light? That's right, it's going to be white in color because the dust particles scatter all colors equally in all the directions. So the beam will appear white. Now let's look at the smaller particles, the air molecules. For example, nitrogen and oxygen molecules. These particles are smaller than the wavelength of visible light. So let's say white light from the sun is falling on the air molecules. Again, we are taking the white light to be composed of red, green and blue. Now let's focus our attention on a single air molecule. The air molecule scatters the different colors differently. And as you can see, the blue color is scattered more than the green color and that's scattered more than the red color. Why? Because different colors have different wavelengths. And shorter wavelengths are more scattered than larger wavelengths. Blue color has the smallest wavelength, so it is scattered the most. And red color has the largest wavelength, so it's scattered the least. In fact, blue color is scattered 10 times more than red color. This is known as preferential scattering. And it happens in particles that are smaller than the wavelength of visible light, such as air molecules. So are you getting a clue why the sky appears blue to us? We know that sunlight is white. Sunlight is made up of all the 7 colors. Now when sunlight enters the atmosphere, the light is scattered by the atmosphere. The atmosphere is mainly made up of air molecules, and there are trillions and trillions of air molecules. As we discussed, each air molecule is doing preferential scattering. It scatters blue color more than the red and green color. So blue color is scattered the most. It's like the air molecules are playing with the blue colored powder and scattering it all around. So whenever we look up at the sky, we see blue color. And that's why the sky appears blue to us. What do you think the color of the sky would be if there was no atmosphere? That's right, black. Just like it appears to an astronaut. Because if there are no particles to scatter the light, the sky would appear black to us. The sun would still appear white. So the blue color of the sky is an optical illusion. It is due to the preferential scattering of light by the air molecules. We know that the sky is blue, but why are the clouds white? Think about what the clouds are made up of. That's right, water droplets and dust particles. As we discussed, these particles are larger in size, larger than the wavelength of visible light. So these particles scatter all colors equally. So when the white light from the sun falls on the clouds, all the colors are scattered equally, and so the cloud appears white to us. Now let's look at why the sun appears red at sunrise and sunset but white at noon. Let's consider the sunset case. Obviously, I have seen more sunsets than sunrises. You need to wake up really early to see the sunrise. To analyze, we need to zoom out quite a bit. So imagine you're standing on the earth like me and looking at the sunset. During sunset, the sun is near the horizon. As you can see, the sunlight has to travel the greatest distance through the atmosphere to reach us. Since sunlight has to travel through such a large distance in the atmosphere, a lot of scattering of light will happen. We know that sunlight is made of white light, the 7 colors, but for simplicity, let's consider the 3 colors, red, green and blue light. Now blue light has the shortest wavelength, so it gets scattered the most. Let's say it gets scattered so much from our line of sight that no blue light reaches our eyes. Similarly, green light is also scattered a lot and it does not reach our eyes. Red light, which has the largest wavelength, reaches our eyes because it is scattered the least. So what will be the color of the sun? That's right, the sun appears red to us. Of course, this is an exaggeration. Small amount of blue and green light also reaches our eyes, but red light reaches us the most since it is scattered the least. And that's why the sun appears red during sunrise and sunset. But the amount of red light that reaches our eyes is much more than the other colors. So the sun appears reddish at sunrise and sunset. Now, why do you think the sun appears white to us when it is above us? Let's say at noon. Once again, let's zoom out and take a look. As you can see, at noon, the sunlight has to travel through a much smaller distance in the atmosphere to reach our eyes. Again, blue color is scattered the most, green color is scattered less, and red color is scattered the least. Since sunlight has to travel through a much smaller distance, the percentage of blue and green color that's scattered is very small. So all the colors of the sunlight reach our eyes. The difference in intensity of the different colors is small, and that's why the sun appears white to us at noon. Now let's talk about danger signal lights. Have you seen these lights at the end of aeroplanes or on the top of a tall building so that the planes know that there's a tall building here? What is the color of these lights? That's right, they're always red in color. Why? Is it because red is the color of danger or caution? No. Let's discuss the physics behind the choice of color here. Imagine there are 3 danger signal lights at the top of a tall building. Red, green and blue light. And they are of equal intensity. Let's say a plane is flying at a far distance. Which light do you think would be most visible to the pilot? That's right, it's going to be the red light. Because red color has the largest wavelength, so it's scattered the least by the air molecules. Red light can travel the furthest distance. So that's why danger signal lights are always red in color, because it's due to the preferential scattering of light by the air molecules. As we discussed in this video, the blue color of the sky and the red color of the sun at sunrise and sunset, these are all optical illusions. Optical illusions due to the scattering of light. And next time you see the red danger signal lights at the end of an aeroplane or at the top of a building, do remember why they are red in color. Because red color is scattered the least. Which reminds me, do hit the red subscribe button for my YouTube channel right now.